Welcome to the session, guys. Now, today's session is going to solve the GATE 2024 NE paper. In that NE paper, we are going to solve in the, manufacturing, that is production questions, as well as industrial and operation research questions. We are going to solve. Have a look on that. So now it is a section B. It's a section B. Manufacturing and production first we will solve, and later on we continue our session in the same section B. What are the industrial questions? Right now we segregate the question type and also number of questions came. 1 mark questions 6 came, that is 6 marks. Okay, 1 mark questions 6 came, and it is going to be a 6 marks. Next, 2 marks questions, 5 questions came, 10 marks. So that here 5 into 2 is equal to this 10 marks, right? Now 10 plus 6, so that total 16 marks came. Now let us see what kind of 1 mark questions came, and which chapter it is came, and what type of 2 marks questions came, and which chapters it came. Then we will discuss all those detailedly, right? Now let us go for first one. Question number 28. The phase presence in perlite are. Okay, what are the phases present in the perlite? Right, this we have been discussed already, guys. Okay, right now perlite. What is the perlite structure? So actually, if I take the steel, and perlite is the alternative layers of ferrite and cementite. Alternative layers of ferrite and cementite. Right now, this is your perlite structure. And it is a alternative layers of ferrite and cementite, right? Alpha plus Fe3C, such that here alpha is a what? Ferrite, we have discussed, and it's a cementite. Now ferrous plate cementite is your perlite structure. So perlite is a ferrite and cementite. Where is that? Austenite and ferrite? No. Cementite and austenite? No. Ferrite and cementite. This is your answer. Okay. So now answer is C. See how simple it is. Okay. We have discussed. I gave the structures as well. Have a look on that, guys. Okay. Go back to our material science note and see that. Then you will find the different structures of the steel at higher temperature as well as the room temperature I provided. Okay, so if you go to my notes, then it will be very easy to solve this kind of 1 mark question. All right, now let us move for the next question. Question number 29. Right now, the earring phenomenon in metal forming is associated with. So in metal forming, where we can find this particular earring defect. Right now, I told you that, guys. Right, did you remember or not? So go back to our notes. So it is a deep drawing component, right? This is a deep drawing component. Now on the deep drawing component, so upward edges. Okay, I just draw a little clearly. So this is your deep drawing cup. All of this. This is a deep drawing cup. Now providing upward edges, right? Now we have already discussed, right? Now these upward edges or projected edges, upward edges or projected edges, we are calling it as a earring defect. All right, guys. So now here it is come under deep drawing component. It is come under deep drawing operation. Okay, all are related to see forging, rolling, extrusion, all are forming. So in the forming process, you will get deep drawing earring effect phenomena in the deep drawing component only. So now your answer is here. Yeah. Your answer is yeah. Hope you understand, guys. Hope you understand. Right now, see how simple questions these are. So we have discussed deep drawing defects. Okay. So now to avoid this earring effect, we are using blank holding force. At that time of blank holding force, if you go, so that you will be able to find out this thing. Okay. Hope you understand, guys. Hope you understand, right? Now let us move for the next question. The grinding wheel used to provide the best surface finish. Which grinding wheel is used to provide the best surface finish? It's another one mark question, guys. So let me explain you how simple and easy it is. Now here I will give you one code to you. Okay, here I will give you one code to you. Now, actually, grinding wheel is specified with the help of some codes. Okay, these are the code. Actually, with the so three alphabets and two numbers, total 5 letters is used for provide. What is that? Well, let me explain you. To specify grinding wheel, specify grinding wheel, three alphabets and two numbers are used. Two numbers are used. This is a one statement, right? Now, for that, I would like to take a small book here, guys. So please be on the line. Now here, 1, 2, 3, 4, and 5. 4 and 5. Okay, right. Now, to guys, here, to remember this, I will give you one statement here. See, attack gate to have a seat in bar. Okay, attack gate to have a seat in bar. Remember this code. Okay, so now first letter is A, right? A stands for, first letter is a alphabet. Now this is a alphabet, right? So attack gate. It's a code, guys. Okay, attack gate, right? Now similarly, Z letter, similarly H letter, similarly C letter, similarly B letter. It's an alphabet. Okay. Now it indicates that type of abrasive particle used in the grinding wheel. Type of abrasive. So what type of abrasive particles used in the grinding wheel? So A stands for type of abrasive particle. So now here type of abrasive particles generally we use Al2O3 and B4C, boron carbide, silicon carbide, and diamond particles, small particles, abrasive particles. These are used. If Al2O3 used, A letter. If B4C used, B letter. And stands for silicon carbide. D is there. So now here A is there. So aluminum oxides are used. Aluminum oxides are used. Next, gate. So gate means it is a structure number. It is a number. That means grade of grinding wheel. It's a number and it indicates that grain size. G indicates that grain size. G indicates that grain size, guys. Okay, grain size. Grain size number. Grain size number. Okay, right. Now, what I'm trying to explain you here, see, these 36, these 36. All right. Now, what I'm trying to explain you here, grain size. G stands for grain size. Okay, this is a type of abrasive. This is a grain size. So now this number indicates that grain size. Okay, next H stands for, it is an alphabet again. Alphabet, and it indicates that hardness of grinding wheel. Hardness of grinding wheel. Dense hardness, or hardness of grinding wheel. All right. Next, C. S Seat. S stands for structure of grinding wheel. Structure of, no, no, it is also a number. It is also a number. Now it's a number, indicates that, structure of grinding wheel. Structure of grinding wheel. All right, guys. Next is B stands for, it is a alphabet again. Alphabet, and it indicates that B stands for bonding material used for making the grinding wheel. Bonding material used to make grinding wheel. To make grinding wheel. Clear everyone? All right, guys. Right now here, this indicates that, grain size. This indicates that, letter. I will give you. See this L L L. So this indicates that hardness of grinding wheel. Hardness. Okay. So whether it is a hard grinding, soft grinding wheel or hard grinding wheel. Now next, number five. Number five is used for, S. Structure number. This is a structure number. Structure number. Right. Last one is used as an alphabet. This is used for, you know for which type of bonding material is used. Vitrified bond. Which type of bond? Okay, so that is vitrified bonding or cell lock bonding or silicate bond, whichever bond is. Okay, so first one is a type of abrasive, grain size, hardness of the grinding wheel, structure of the grinding wheel, and also bonding, type of bonding used. Okay, now if you want, I can write simply. So this indicates that, what is that? Type of abrasive. Abrasive, type of abrasive particles used, right? This indicates that grain size of the particles. So this is the aluminum. Which type of? That means small grain size or large grain size. Grain size it indicates. Right? H indicates that. H indicates that hardness of grinding wheel. Hardness of grinding wheel. Okay. Hardness of grinding wheel. GW means grinding wheel, right? Next, S indicates that structure of grinding wheel. Whether it is a open structure, that means I'll show you that. We have a diagram. Structure of grinding wheel. That means structure of grinding wheel. Next, B stands for bonding used. Type of bond. Vitrified bond or silicate bond. Alright, I hope you understand now. Right now here, which provides the best surface finish? We need to find the best surface finish. Which type of grinding wheel in the specified four options? Best surface. Right now here, see guys, let us go to see this grinding wheel. Now here, these are the abrasive particles and they mention size. Here, if the abrasive particle size is more, then it occupies more contact area between the workpiece and tool. Now, if I go for grain size, large grain size, small grain size is used for rough grinding. Okay, small grain size are used for rough grinding, right? So small grain size, small grain size for rough grinding. See, this is a small one, rough grinding. Next, this is a one statement. Next, second one is a large grain size. Large grain size used for good surface finish. Good surface finish. All right, guys. Right now here, let me know. Sir, if it is a small one, then rough grinding. If it is a large one, grain size. So let us go back to our slide. Now, which one having the highest grain size? Grain size, second letter. Which one having the highest grain size? D. This grinding wheel is going to be provide the good surface finish. I hope you understand, guys. I hope you understand. Right? Answer is D. Right? Now, whichever having the grinding wheel large grain size of abrasive particles. See, if it is a large grain size, so that smooth operation is going to be happen. Okay. I hope you understand. I hope you understand. Right? This type of you have to evaluate like that. Use this code for finding this one, so that it will be very easy to you to solve this question. Clear, everybody? Hope you understand. Hope you understand, guys. Please do respond. Now let us move for the next question. Which allowances provided to pattern for easy withdrawal from a sand mold is? Okay, so which type of allowances? We have discussed allowances. All right, now we have a shrinkage allowances, machining allowances, draft or taper allowances, and also shake allowances and distortion allowances. Right. So first one, we need to understand one thing. Right. Now evaluate the question. Finishing allowances, there will be no finishing allowances. However, machining allowances, we call it as a finishing allowances. But finishing allowances are not provided to easy withdrawal. Here, when what type of allowances are going to be provided in order to easy withdraw? So I gave you the diagram. Shrinkage allowances are also not provided to easy withdraw. Shrinkage allowances to overcome the shrinkage happen during the solidification. Distortion allowances, this for only U1 V shapes only, right? U1 V shapes casting, we use distortion allowances, right? Now, what's your answer? Shake allowances. What's your answer? Shake allowances. And however, shake allowance is your answer. Let me explain you that also. Right. Now, let me explain you this in a simple way. Right. Now, let me explain you. Taper or draft. Taper or draft and shake allowances. Both are used for easy withdrawal. Both are used to easy withdraw the pattern, easy withdraw pattern, easy withdraw pattern from the mold, from the mold, isn't it, guys? Right? So this is a statement, but here both are there. Two allowances we can use. One is a taper or draft, and another one is a shake allowances. But here taper is not mentioned. That is why your answer is the shake allowances, right, guys? Now I just draw the simple diagram in order to elaborate the question clearly. Right, guys? Now this is a mold what you have prepared. Okay. Now let me draw the pattern as well. Now this will be your pattern. Right. Now this will be your pattern. So shake means you have to shake this side and this side, left side and right side, and forward and backward. You just shake the pattern such that what happen. So your cavity, there is a gap between the mold and pattern will be happen, so that this is all your sand particles. All right, all are the sand particles, right? Now whenever the gap is created, so that you can easily withdraw the pattern, this we have already discussed in the class, guys. Okay, go to our note. I have drawn clearly very clear diagram, so that you will be able to understand very well. Okay, shake allowances and taper or draft allowances easy withdraw the pattern. So for easy withdraw the pattern from the mold, we can use both, either taper or shake allowances we can use. Okay, but here taper is not given in the option. That is why we select the shake allowances. I hope you understand, guys. Okay, now let us move for another question. Right. So most of the suitable electrode material used for joining low carbon steels using gas metal arc welding. Okay, so we can also call it as a MIG welding also. Metal inert gas welding, we can also call it as, right? So let me write it. MIG welding. Okay, MIG MIG welding also we can call it as. Right. What is that? What is the most suitable electrode material? Most suitable electrode material used for joining which type of material? Low alloy steels. Low alloy steels. Right? Right. Now here in the question itself answer is there. Right? So for joining this steel, obviously whichever the properties are very close to the steel, that material we use as a filler material, isn't it guys? Right? Suppose see that these are my two plates to be going to be joined. These two plates are going to be joined with a welding process. Now what they said, it is a low alloy steel. It is a low alloy steel. Two plates are low alloy steels. All right. Now, if you want to join this, right? What is the filler material they're asking? Okay, what is the electrode material they're asking? Right now, whichever the material very close to the properties of low carbon steel, that one we'll select. So now, for what are the close properties? Copper. Do you think that copper is very close to the low alloy steel? No. Cadmium? No. So whenever you're going to join low alloy steel, obviously you prefer to use low alloy steel. So that filler material here, what you're going to fill? Low alloy steel only. Okay. In the question itself, how simple and easy if you understand the proper tungsten. No. In MIG welding, we are using consumable electrode. It is a consumable welding process. Clear everybody? I hope you understand. Please do respond, guys. Please do respond. All right. Now it is a MIG. It is a MIG. Why tungsten? Why not tungsten? Means MIG is a consumable welding process. Consumable electrode is used. Electrode material is used. Right. Now here, your welding wire, your welding rod, filler material, your welding rod will be the low alloy steel. Okay. Low alloy steel. I hope you understand, guys. This is what your filler material or electrode. Filler or electrode. Hope you understand, guys. I hope you understand. Right now, your answer is here. C. Right, guys. Right. Now let us move for next question. Right. So the proprietary functions in CNC, that means computer numerically controlled CNC machine. Question number 33, guys. Proprietary functions. Proprietary functions. G codes are also called proprietary functions. I told you. Okay, please go to our note. So I told you that G codes are also called what? Proprietary functions. Right? In CNC part programming, so we are using the proprietary functions that we call it as a G codes. What we call it as a G codes. So that your answer is G codes, right? Answer is, A. Hope you understand, right? In G codes are also called proprietary functions during writing part programming in CNC. During writing part program in CNC. I will write it properly. In CNC. Okay, right. In computer numerical machine, for the CNC machine, while you are writing the part programming, we use G codes. G code are also called as a preparatory function. So your answer is G. Okay. Now see what is the question. The preparatory functions in computer numerical controlled CNC machine program are denoted by the alphabet G codes. G codes, all right. M codes and P codes. M codes are the these are all not preparatory functions. Okay, these are the miscellaneous codes we call. Okay, P and O are not at all our CNC program. Okay, that is why your answer is A. Okay, hope you understand. Right, now let us know whatever the node instructions I gave you in the class, you just go through that carefully so that you will be able to understand very clearly, very clearly. Okay, right, now let us move for next question. Right, now here let us go for the question which we are going to solve. Right, it is a question from metal cutting, guys. It is a question from metal cutting, so I'm sorry, here it is a question from advanced machining process, right? Questions from advanced machining process, right? Next is, it is a question from welding, one more question, right? And it is a question from casting, right? Now here question from machine tool operations, right? Now it is a question from metal forming. So every chapter having weightage. Okay, that is why it is a material science question. Okay, I hope you understand, guys. I hope you understand. Right, now have a look on this. Now next question is, it is a question from, what is that, cutting tool life, metal cutting tool life equation, right? Now read the question carefully, right? Now it is a 2 marks question, NAT. It is a 2 marks question, NAT, right? Now a cutting tool provides tool life of 60 minutes. Tool life is given, it's a 60 minutes while machining with a cutting speed of 60 meters per minute. Right, now when the same tool is used for machining the same material, okay, it provides the tool life of 10 minutes at a speed of at a cutting speed of 100 meters per minute. Right, now here two cases are given. Right, now here it is a tool life T1 we say, now it's a cutting speed we say V1. Now same tool life they use, sorry, when the same tool is used for machining the same material, it provides the tool life of this one. Again tool life is given at a corresponding cutting speed of V2 we say. Right, if the cutting speed is changed to 80 meters per minute for the same tool and work material combination, the tool life computed using Taylor's tool life model is, right? Now equation is very clear. Now here it is a V3, right? What we need to find? Tool life in minutes. That means T3 you need to find, right? Now whenever you engage these kind of questions, don't get exact, guys. Okay, so this model we have solved in the class. Okay, now first you write the given data. First you write the given data. What is given? T1 tool life is given 60 minutes. So now cutting speed for the first case is given. Now it is going to be a 60 meters per minute. All right. Now next case 2. Case 2 tool life is given T2 is equal to, it is going to be a 10 minutes only. Now V2 it is given, it is going to be a 100 meters per minute. 100 meters per minute. Right, now third case is also given, that is T3 we don't know, T3 we need to find, and V3 we need to V3 is given, that is 80 meters per minute. Right, now N is not given, then immediately what you need to do, guys, what you need to do, now find the N equal to, we know the formula, that log uh, V2 by V1. I gave you the derivation, please go through that. Log T1 by T2, isn't it, guys? Log T1 by T2. All right, now substitute that so that you will get N. So now N is equal to log V2. How much V2? 100, and V1 60, 100 by 60, and is divided by log T1 by T2, that is T1 60 and is divided by 10. Clear, everybody? Right. Now, if you solve this, then you're going to get your n value 0.285. 0.285. Right. Now you got the n value. First, whenever you encounter this kind of questions, simply you find n. Right. Now I'll write equation here. Have a look on this. Have a look on this, guys. Right. Now here, can I write like this? V1 T1 power n is equal to, V2, V3 and T3 power n. Isn't it, guys? Okay. Same material and same machine, same cutting tool machine. That is why here C is constant. That is the reason why here. So we know the equation that Vt power n equal to C. So C is same for all three cases. C is same for all three cases. So it is a first case, it is a second case, because same material, same machining conditions, right? That is the reason why here I wrote that V1 T1 power n equal to V3 T3 power n. Very simple. Substitute all the values. You know V3, we know V3, right? We know V1 and T1 as well, and n also we had find, right? Now let us go to substitute the equation, right? Now let's go to the next step. That is, I know that it is a V1 T1 power n is equal to V3 and T3 power n, right? Now we know that V1, how much V1? V1 is 60 and T1 is also 60, right? Now here 60 and here 60 to the power 0.285 is equal to V3. How much V3? So V3 is here 80, and it is going to be a 80. It is going to be a 80, and T3 to the power 0.285. 0.285. Got it? Now we know only one unknown parameter, that is a T3 only, right? Now here T3, right? Now how can I write my T3? So now here it is going to be a 60 into 60 to the power 0.285 and is divided by 80, and it is a whole to the power 1 by 0.285, right? If you solve this, then I'm going to get my tool life approximately 21.87 minutes I get, right? Now your answer may be vary from your answer, it is a NAT question now. That is why here it may be vary from 21 to 22.50. No problem. Okay, 22.5. 1 minute, 1 minute. It's going to be a 22.50 minutes. All right. So now here answer may be vary in this much. Now let us go back. So night to life T3 maybe varies from 21 to 22.50. Clear, everybody? I hope you understand, guys. I hope you understand. So simple question, 2 marks question. How simple it is? How simple it is, right? Right. Now I hope you understand. Right? Clear, everybody? Clear, everybody? Right. Now let's go for the next question. Yeah, it's a casting. Another NAT question. Another NAT question. Right. Now aluminum is casted a cube shape mold having the dimensions 20 by 20 by 20 mm. Another mold of the same material is used to casting a sphere, right? Now here shape of the casting is cube, same material sphere, right? Of aluminum having the diameter. Here diameter of the sphere also given, dimensions of the cube also given. Now pouring temperature for the both cases is same, right? The ratio of solidification time of the cube, solidification time of the cube shape to the solidification, the ratio of solidification times of cube shaped mold to the spherical mold. Cube shaped mold and spherical mold, right? So solidification time we have already discussed, right? What is the solidification time according to the Bernoulli's rule? Bernoulli's rule, what is the solidification time? Solidification time is equal to, it is going to be a k into volume of the casting divided by surface area of the casting to the square. Okay, V stands for volume, SA stands for surface area. Number of lot of questions we have solved this kind of questions, right? Now let us first draw the cube. Okay, first draw the cube, right? Now let me draw the cube guys. Right? Now here a cube is there, all dimensions are equal for the cube, isn't it guys? That is why, yeah, what are the cube dimensions are given? 20, 20, 20. So width, thickness, length, both are all are 20, 20, 20 only, right? Now here, so I just have a, this is 20, right? Exercise is 20, right? Next is I'll draw the sphere, and the sphere is, its diameter is mentioned. How much guys? Its diameter is mentioned 20 mm, right? Diameter of the sphere is equal to 20 mm, right? Now this is also in mm guys. All right. Now what we need to find? Now what we need to find? Now here what we need to find? So the ratio of solidification times of cube shaped casting to the spherical molds, right? Now here solidification time of cube, right? Now this is a solidification time of sphere, right? Now solidification time of cube is k into volume of the cube divided by surface area of the cube, right? Now here also solidification time of spherical shape, so volume of the sphere divided by surface area of the sphere whole square. Hope you understand guys, hope you understand, right? Now for solving very easily this, yes, now what our objective is that, our objective is to find the ratio of solidification time of cube is divided by solidification time of sphere. So this ratio we need to find, right? Now what I do is I'll first find out that solidification time of cube. Okay, right? So cube size I'm taking A and sphere radius I'm taking R, right? Now first we'll calculate solidification time of cube. Solidification time of cube. So that is K into, it is cube, A cube is divided by 6A square is the surface area to the whole square. All right. Now here K into, it is A cube A square will get cancelled, A by 6 to the square, and here A equal to 20 na, so cube size equal to 20 mm, right? That is why K into, it is a 20 divided by 6. No, oh yeah, k by 6 whole square. Right now here I can write it is k into, it is 20 by 6. 20 by 6 means 10 by 3 we will write to the square. Alright, now let us find that solidification time of sphere. Right, sphere radius I'm taking, or you take it as a sphere radius. Sphere radius. So that is gonna be a 10 mm. Actually radius is D is a diasphere. D is a diasphere, that is equal to 20 mm. Alright. Now here again K into, so volume of sphere 4 by 3 pi r cube divided by, surface area of the sphere 4 pi r square to the square. Alright guys, right? Now here it is a volume of the cube and it is a surface area. Volume of the sphere and surface area of the sphere, right? Now 4 pi r square will get cancelled. So that r by 3 you will get, right? Now here r by 3 to the square, right? From here k into, it is r is 10 by 3 to the square. All right, guys. Right now, what we need to find? T cube by T square. Right. Now, T cube and is divided by T square. All right. Now, from here, I'm going to write it as T cube. So K into 10 by 3 to the square and is divided by T square K into 10 by 3 to the square, right? Now here if I write this kk, is get cancelled. Why? Because all are the same material, both the cube and sphere, same casting condition, same this one, right? Now here I can write it is 10 by 3 into 3 by 10 to the whole square, right? All are get cancelled, so that we are going to get it is a 1 to the square, such that your answer is 1, right? Now answer 1. All right, the ratio between the cube is, you may get confused here, but it is only 1. Right, guys. I hope you understand. I hope you understand. Right now, let us go for the next question. Let us go for the next question, guys. Now, yeah, again, metal forming operation. Okay, a blanking operation is performed on C20 steel sheet is obtained in a circular disc having diameter of 20 mm and thickness of 2 mm. Allowances are given 0.04 is provided. The punch size used for the operation is, the punch size is going to be used for the operation is, that is what we need to find, guys. Extend. All right, guys. Right now, let us go for, we just highlight the things over here. So, blanking operation, clearly mention it is a blanking operation, right? Now, it is another 2 marks question. How simple it is, I'll tell you, right? Now is obtained, disc diameter is given, D is given, and thickness is given, and clearance is given, right? This is a clearance, and this is a thickness, and this is a D. Now, what we need to find? The punch size we need to find. Punch size we need to find. Now, write the given data, guys. Write the given data. Right. So, what is the given data? Blank diameter. It is a blanking operation. That is why blank dia D is equal to, it is going to be a 20 mm. All right. Now next, thickness of the blank T is equal to, it is going to be a 2 mm. Right. Now clearance is equal to, it is going to be a 0.04 mm. All right. Now what we need to find? Punch size. Punch size we need to find. Right. Guys, all you know that. Now I gave you one statement here. However, we have discussed in the class. Right. Now in blanking operation, in blanking operation, in blanking operation, in blanking operation, I gave you one table in our class, regular class. Go to there. Okay? In blanking operation, blank size equal to die size. Not this units. Blank size equal to die size. And one more statement: clearance provided on punch. Alright guys, now let's solve the question. How simple and easy it is. Right? How simple and easy it is. Right? Die size is equal to blank size. So what is the blank size here? 20 mm. Okay, right. Now punch size is equal to die size minus 2c. Die size minus 2c. What is die size? 20 mm. 20 minus 2 into 0.04. Such that it is going to be a 20 minus 0.08. Now it is going to be a 19.92. It is going to be a 19.92. What do you say, guys? Right now your answer is, it must have to 19.92 mm. All right, it has to vary like that only. Okay, right. Now clear, everybody? I hope you understand. I hope you understand. Right now, if you remember these 2 points what we have discussed in the class, then it is very easy to solve this kind of question. Hope you understand, guys. Hope you understand. Right now, let us move for the next question. Right. In arc welding process, the welding voltage and current are 30 volts and 200 volts. Right. In a welding process, welding question, guys. 2 marks question again. Okay. Right. Now here voltage is given and current is given. Right. Respectively, the cross sectional area of the joint is 20 mm square. Area of the weld also given. The welding speed is also given. Right. Now the heat input required to melt the material is 20 joule per second. Actually, guys, this we have solved in the class. It is a controversial question, right? Now here, actually, it is 20 joule per mm cube. It has to give 20 mm per, 20 joule per mm cube, right? Now we have solved this question in the class. Go through that. However, we'll solve here also. The percentage of the heat loss to the surroundings during the welding process is kept. Right? Now, first, let me write the given data. Let me write the given data, guys. Right. Right. Now, what is given data? Welding voltage V is equal to 30 volts. Right. Now, current I is equal to 200 amperes. Right. Now, welding area AW, right, is 20 mm square. Next, welding speed V is equal to 5 mm per second. Right. Next is unit melting energy. Unit melting energy 20 joule per mm cube. Okay. Now what we need to find? Heat transfer to the surroundings. This is what we need to find, right? Now, guys, I gave you one relation. Right? If you remember that, then it would be very, very easy to solve this kind of question. What is that? V into I into melting efficiency into heat transfer efficiency is equal to, it is going to be a area of the weld bead into welding speed into unit melting energy. Okay, now here this term is not given, right? If you observe that unit melting efficiency is not given, that is why you just remove this one. Right now here everything is given. What we need to find? This fellow we need to find. Write the equation. Right, write the equation. Heat transfer efficiency to the surroundings is equal to, it is AW into V into unit melting energy is divided by V into I. V into I. Now substitute the values. Substitute the values, guys. How simple! Oh my god. Now area of the weld 5 into area of the weld. Oh my god, 20. It is going to be a 20 into welding speed 5 into unit melting energy again 20. Right. Now it is going to be a V is 30 and it is going to be a welding current is 200. All right, guys. Right now here, if we are able to solve this, so 0 0 and 0 0 will get cancelled. Now it is going to be a 10 and 20. 5 5 to 10 and 10 to 20. 20 is divided by 60. such that I can write it is a 2 by 6, then it is going to be a 1 by 3. It is a percentage na, such that it is going to be a 0.66 into 100, such that it is going to be a 66.66 percentage, right? Now your answer is here. Your answer is here. Here your answer is 1 minute, guys. Right. Answer 66.66 percentage. Hope you understand, guys. Hope you understand. Right now, how simple it is. If you remember this relation, what I gave you in the class, so that it would be very easy to solve this kind of question. Right now, let us go for another question. Now here, see, it is going to be another question. Machine tool operation question. See that a flat surface of a C60 steel having dimensions of 100 mm length and 200 mm width. Okay, 100 mm length and 200 mm width. Right now, produced by HSS slab mill cutter, having 8 teeth on the cutter, has 100 mm diameter and 200 mm width. Right, the feed per tooth is 0.1 mm. Then the cutting velocity is 20 meters per minute and depth of cut is 2 mm. The machining time required to remove the entire stock is right. Now we just highlight with the data what we have. Right now here, length of the workpiece is given small l. Right, width of the workpiece is given say w. Right, next, produced by slab mill cutter. Slab mill cutter. Right now, slab mill cutter I am showing here. See here like this. Right now it is a view and it is a front view. This is slab mill cutter and it is a workpiece. So that here, this is the cutter. Now what they said, 1 minute. It is having 8 teeth. 8 teeth it is having. 8 teeth we call it as a Z in our data, right? And has a diameter of the cutter. Diameter of the cutter. So diameter of the cutter is 100 mm. Now diameter of the it is going to be a 200 mm. Oh, sorry, width of the workpiece is 200 mm. Sorry, tool. The feed per tooth. So here feed per tooth we call it as FT, right? Cutting velocity V is given, right? Now depth of cut D is also given. Now machining time we need to find, right? Now here let us go for guys. First write the given data. Right now what is given data? Length of the workpiece is equal to, it is going to be a 100 mm. Right now width of the workpiece, say it is going to be a 200 mm. Right now Z, number of teeth on the cutter is 8. Right now diameter of the cutter is 100 mm. All right, now the feed per tooth, F suffix T is equal to 0.1 mm per teeth. All right, next is cutting velocity is given 20 meters per minute. All right, now here depth of cut D is equal to, it is going to be a 2 mm. Right now what we need to find? What we need to find? Machining time we need to find. Right now machining time is equal to, it is going to be a length of the tool travel is divided by ft into z into rpm of the cutter. Right, this is what we have discussed in the milling. Right now let us go for L. So length of the tool travel. Length of tool travel. Length of tool travel. Clear, everybody? So how we can calculate it is approach, compulsory approach 1 plus length of the job plus approach plus overrun. But see here guys, so this approach and overrun is not given, such that my length of the tool travel is equal to compulsory approach plus L. All right, now here the thing is here, coming to here, see here how to calculate this. So for calculating this we need to understand which type of milling it is. Okay, which type of milling it is, that is what we need to find. Right guys, right now see, in compulsory approach it is in slab milling cutter. So whenever slab milling cutter is used, so now this will be your your depth of cut, say D, right? Now, whenever slab mill cutter is used, then your AP1 is equal to, it is going to be a, so D into D minus D under root. Isn't it, guys? Right? Now, it is a slab mill cutter, right? Now, let us move for calculating the AP1. Fine. So, now your compulsory approach AP1 is equal to, it is D into D minus D under root. So, where D is a diameter of the cutter, right? Now, here depth of cut is 2 and 100 minus 2 under root. Now, it is going to be a 2 into 98 under root. Right. Now, if you solve this, then you are going to get this under root 196, such that it is going to be a 14 under. All right. Now, AP1 is came. Now, let's find out length of the job. So, here length of the tool travel AP1 plus L. So, now here AP1 is 14 mm plus length of the length of the job. Length of the job is 100. Right. Now, it is going to be a 100. Such that it is going to be a 114 mm. Okay. Now, let us see. Now, we have found this one. FT, we found this one. FT we have already. FT we have already, right? Now, Z we have already, right? Now, N we need to find. N we need to find. Now, from the given data, your cutting speed, V is equal to how much it is? Is pi d n by 1000. Pi d n by 1000. But here it is given 20 is equal to pi into d is 100 into n and is divided by 1000, such that I can write my n is equal to 20 into 1000 and d is divided by pi into 100. Right now, from here, if I am able to solve this, then I'm going to get it is a 63.66 RPM will come. Right now, our final objective of the answer is machining time. Machining time is equal to Tm. T suffix M is equal to, it is L by Ft into Z into N. Right now, my L is how much? My L is 114. 114 divided by Ft. How much, guys? Go to that and see. Ft is 0.1 and Z is 8 and my R is 63.66. Now, if I able to solve this, then I'm going to get it is a 2.24 minutes. Right? 2.24 minutes, right? So it may be vary from 2 to 2.5. Okay, no problem. Okay, right. Now it may vary 2 to 2.5. Right. Now your answer is vary from 2 to 2.5 minutes. All right, guys. Right. You understand like that. So only here the biggest challenge here, right? You need to go for L. How to decide L? Not this also. However, you can do this, but my problem is that how to decide AP1? How to decide AP1? How to decide AP1? Right? Based on the slab mill cutter, I have selected my compulsory approach is D minus 1. Okay. Right. Hope you understand, guys. Hope you understand. Right. Now let us go for. Okay. Hope you understand, guys. Hope you understand. Right. Now let us move for. That's all. And all the manufacturing questions have been solved here. Okay. Right. Now let us move for. We will solve some industrial questions also. Right. Now. Right, guys. Let's see some same gate mechanical 2024 paper. In that we are going to just now we have seen that some manufacturing and production questions. Now let us see some section B in that industrial and operation related questions. Right now, let's see. We have segregated the questions. That is question type 1 mark question and 2 mark question. 1 mark questions came 2, and 2 marks questions came 3. So total 5 questions and 8 marks. Okay. So now here 3 into 2 is going to be a 6, and here 2 into 1. See, so total is 8 marks. All right. Now let us see solve these 5 questions. Right. Now let us move for first question. Right. Now see this MCQ question, guys. Options are given. Question number 34. So read that. A set of jobs U, V, W, X, Y, Z arrive at a time t equal to 0 to produce a production line consisting of 2 workstations in series. Each job must be processed by both workstations in sequence. That is, first followed by the second. The processing time in minutes for each job on the workstation in the production line are given below. Right now, what question it is? Job sequencing and scheduling chapter. So I told you that we have solved so many questions. So now here, in jobs, 2 missions, right? In jobs, 2 missions, guys. Right. In jobs, 2 mission model, right? Now the sequence in which jobs must be processed by the production line if the total make span of the production is to be minimized. Okay. Now sequence in which the job must be proceed. What we need to find? Sequence we need to find. So what model it is? In jobs, you know, and 2 missions. Right. That means 2 workstations. 2 missions and 2 workstations, right? Now jobs U, V, W, X, Y, Z and workstations 1, 2 is given. Their processing times are also given. Clear everybody, guys? Right. Now let us n jobs 2 missions. Which one we follow? Jansen's algorithm. Okay. Now we used to follow Jansen's algorithm for n jobs 2 missions, right? Jansen's algorithm. Johnson's algorithm. Clear? Right. Now let us rewrite this clearly. Now go for the next step. Now here, guys. Actually, don't panic. Actually, we have not solved like this. Okay. Now we have solved some other model, not model in this way. Jobs, workstation 1, and workstation, and next is workstation 2. All right. That means workstation 1 and workstation 2. Jobs U, V, W, X, Y, and Z. Right now their processing times. Now their processing times. Right. Now here their processing times. I'll write 573,468. 5, 7, 3, 4, 6, 8. Right. Next 4, 6. Now again 6, and again 8, 5, and 7. All right, guys. These are the things. Right. Now here, according to the Johnson's rule. So what Johnson's rule telling that? According to Johnson's algorithm. Johnson's algorithm. I told you one simple step. What is that? How many jobs are there? 1, 2, 3, 4, 5, 6 jobs are there, right? You just draw the 6 job, 6 blocks you take. 6 blocks you take. 1, 2, 3, 4, 5, 1, 6. And what I said, guys, according to our this, so this side is workstation 1, this side, and this side is workstation 2. Right now, according to our procedure, right? According to our procedure, Johnson's algorithm, find the minimum processing time among the all jobs. Find the minimum processing time among all jobs. So among all jobs, what is having minimum processing time? So W job having in workstation 1 minimum processing time. Right now here it is a workstation 1 side. So your workstation 1 side, here it is going to be a W. Right now Whenever it is gone, then you just strike out this, guys. It is strike out, right? This is already assigned in the sequence, right? Next minimum is some 4, right? 4 here is there, 4 here is there, 4 here is there, and 4 here is there, right? Now which one we are supposed to select, right? So now here 4 8. So whenever x having processing time in workstation 1 4 comma 8. Now similarly we also having 2, sorry, this you also having 5 comma 4. So whenever we encounter with the same, then what I said, which one having the minimum credentials, that one you select. So in that, this is having minimum processing times compared to this one, right? It is 5 4, it is 4 8. That is why you select. So now you processing time workstation 2 side. That is why here you write it is you at the workstation side 2. All it is. Right? Next up. So whenever you drawn this, then immediately you just strike out this also because it is assigned. Right? Next minimum. What is the next minimum? After 4, anywhere 5? No, no. Oh, yeah, 5 is there. Right? Now select this 5. So 5 Y job having workstation 2 side. Workstation 2 side. That is why here you write here Y this side, workstation 2 side. All right. So based on the processing time, it is settled in the workstation 2. That is why workstation 2 side you have to run. Right. Now after that you also strike this because we have arranged. Next, after striking all this, which one is having minimum? This one, U, V. V job having 6. Right. Now no 6 are there. Right. No 6 are there. Oh, yeah. X also we have assigned. Yeah, X is not there. Oh, fine. First we'll see this. Now, no, guys. Somewhere we did the small mistake. So after X, next processing time is X. That is why 1 minute, guys. 1 minute. 1 minute before we are doing this. Y. So here you have assigned. You have assigned. So after you assign, then X having 4 comma 8. That is why X you write here. So then strike out X also. After striking all this, what is the minimum here? 6. So that your V will come this side. Now guys, somewhere we did small mistake. Y. Right? Now here Y only. Right? Because before 6, 5 is there. That is why we strike out this. Next 6, V. This side only. This side only. Right? Now only remaining is Z. Right? Now your job sequence is W X Z V Y U. Right? Search this where it is. So W X Z V W X Z V Y U. So your answer is yeah. Okay. Now answer is yeah. Okay. So that is answer is yeah. Hope you understand, guys. Hope you understand. Right? Clear everybody, guys? Clear everybody? Right? Now let us go for another question. Right. King model. We have solved many more questions in that also, right? Now let's move for that. Read the question carefully. In queuing system has one single server workstation that admits in an infinite long queue. The rate of arrival jobs and queuing system follows the Poisson's distribution with mean of 5 jobs per hour. Arrival is 5 jobs per hour, right? Immediately you write that arrival rate, so generally lambda we preferred, we have chosen according to our job. 5 jobs per hour. 5 jobs per hour are coming into the system. The service time has a server exponential distribution mean of 6 minutes, right? Now here service time. So service time we indicate mu, right? Mu is equal to 6 minutes each. Okay, right. Now here you just convert this into hour, right? Now here 10 per hour is mu, right? Now in steady state operation in queuing system, the probability that the server is busy, not busy at any point in time. not busy at any point in time. Right now, here we have already discussed this formula. Right? Let me write that. So probability, the system is not busy. Probability that system is not busy. All right. So then it is going to be a 1 minus lambda by mu, right? So go to our formula so that you will be able to find 1 minus 5 divided by 10, 5 divided by 10, such that it is going to be a 10 minus 5 divided by 10, such that it is going to be a 5 by 10, such that it is going to be a 0.50. The probability that, so 50% chance the system is not busy. Now, where is your answer? How simple and easy question. Go to our formulas so that you will be able to solve this question just like that. Okay, just like that. All right, guys. Now let us move for another question. King model, inventory control, inventory control. Okay, king model, inventory control. You have to see, right? Now see, a company order gates conditions identical to this consider the economic order quantity model in inventory control. Okay, so it is a basic inventory model only, basic EOQ. The annual demand is 8,000 gates. The cost per order is 300 rupees, right? Now C naught is given and annual demand is D is given, and the holding cost, that means carrying cost, is 12 rupees per month, right? Now the gear, for the gear, the company uses an order size that 25% more than the optimal order quantity determined by the EOQ model. What they said, that remember this statement very carefully from here to here. The company uses order size that is 25% more than the optimum order quantity determined by the EOQ model. Okay, that means whatever the economic order quantity we are finding, whatever the economic order quantity we are finding, more than 25% of that they are ordering. More than 25% they are ordering per order. Actually, we used to find the EOQ for ordering the what is the optimum order quantity. But in this problem, particularly, they said that they are ordering 25% more than the EOQ quantity, right? Right now, the percentage change in the total cost of ordering and holding inventory from the associated with the optimum order quantity. Okay. Now, what they're telling that if they order 25% more than the EOQ quantity, what is the total cost? Similarly, at EOQ, what is the total cost? Then, if they order more than 25%, what is the total cost change in price? What is the total cost change in price? I hope you understand, guys. I hope you understand. It's a simple logical question, right? What I'm trying to tell you here. So, we need to find the total cost at the EOQ quantity, and also we need to find the total cost at the more than 25% of the EOQ quantity. Then we need to find that price change of the total cost of if I order more than 25% of EOQ, and we need to, whenever we use to EOQ quantity to order, what is the total cost? Difference change in price we need to find. Okay, now let us solve this question. Right now, first write the given data. First write the given data, guys. Now demand, annual demand is equal to how much? 8,000 gates. 8,000 gates per annum, right? Now order cost, ordering cost is equal to, it is 300 rupees, right? Now carrying cost 12 rupees per month, 12 rupees per month, right? Just convert this value to per annum, right? 12 into 12, such that it is going to be a 144 per annum, right? Because this also per order, this also per annum, this also per annum, right? Next is everything is given now. Right. Now, first, actual quantity order. Okay, the company actual quantity order. The company order 25% more than EOQ quantity. 25% more than EOQ quantity. So according to company data, that means according to the problem data, so now they are ordering 25% more than the EOQ quantity. So actual quantity, say actual quantity they are ordering 1.25% of the EOQ. Okay, actual they are ordering per order 1.25 into EOQ quantity. Right now, at total cost we need to find at actual quantity. Total cost we have to find at the economic order quantity. Right. First we'll find the economic order quantity. Then we will move forward. Right. Now, first EOQ, economic order quantity. So what is the formula? Basic 2DC naught divided by CC under root. Right. Now 2 into, sorry, not 2000, 8000 guys. 2 into, it is going to be a 8000. 2 into 8000 into C naught is 300, and this divided by 144 under root. So that your economic order quantity is going to become so 182.5. Okay, 182.5. So now total cost at EOQ. Total cost at EOQ. I'll write full form, that's better. Total cost at EOQ. So now here TC at economic order quantity. I gave you the formula. Did you remember or not? Right. So 2 DC naught into CC under root. Right. Now here is going to be a 2 into D 8000 into order cost 200. Sorry, 300 into it is going to be a 144 CC. Right. Now under root. Now here your total cost is going to be 26920. 26920.4 rupees. All right. Now, so actual quantity company orders. This is a economic order quantity, and this is a total cost at the EOQ. But company not ordering this one EOQ. They are ordering this one, right? Right. Now, actual company orders. Actual quantity company orders. Yep. Actual quantity company orders. Right. Now here it is going to be a guys actual quantity Q actual I said. Right. Q actual is equal to, it is 1.25 into EOQ. Right. Now here 1.25 into, it is going to be a 182.5. All right guys. Right. Now how much you want to get? Now here you are going to get it is at 228.125 units. They are going to be ordered. Right. So they are not following EOQ according to the problem. They are going to be follow this much quantity they are ordering per every order. So now what is the total cost at this total actual? Okay. So total cost at actual quantity order. Okay. At actual quantity order. So can I write like this? Total cost at Q actual. Right. Now here, what is the total cost? What is the total cost, guys? I have this. We have discussed already. Right. Now average inventory into CC plus number of orders multiplying with ordering cost. So that you will get the total cost. Right. Average inventory, how come? Q actual divided by 2 average inventory into CC plus number of orders Q actual No, not Q actual. Demand by Q. Now here demand by Q actual, so that you will get number of orders. So that ordering cost. Right. Now what is the Q actual? 228.125. 228.125. Now total cost at Q actual. Right. Now actually company orders. Right. Now it is going to be a 228.125 is the actual quantity divided by 2 into carrying cost is 144 plus number of orders D 8000 divided by actual quantity order 228.125 into ordering cost is 300. Now if you solve this, then I'll get my total cost at this stage is 26945.54 rupees will come. Now what we need to find? What we need to find? Go to the problem. We need to find. We need to find the percentage change in the total cost of ordering and holding inventory from the associated with the optimum order quantity at optimum order quantity. Clear everybody, guys? Clear everybody? Right now here, if they order economic order quantity, what is the total cost? If they order more than 25% of economic order quantity, what is the total cost? That is what we find. Now, percentage change in the total cost. We need to find percentage change in total cost. Now, here final TC actual Q actual minus TC at EOQ divided by total cost at EOQ. Total cost at EOQ multiply with 100, so that you will get the change in price of the change in total cost. So what is the total cost? If they order actual quantity, it is going to be at 26945.54 minus economic order quantity total cost. This is right now 26920. 26920 point how much? 4. Now this is divided by 2C at EOQ, that is 26920.40 into 100. Nothing is, guys, final minus initial by initial, so that you will get change in percentage. That's it. Right now, if you're able to solve this, then you're going to get it is a 2.5 percentage. All right. Now, if I go back, so what's your answer? My answer is this much. Now, answer is going to be a A. All right, guys. Hope you understand. Hope you understand. Right now, let us move for another question. Hope you understand, guys. Right now, again, another 2 marks question, linear programming problem question. Right now, have a look on this. I just read the question and we will solve this in a simple way. Right now, at the current basis feasible solution, basic feasible solution is given. V0 is epsilon r power 5. The simplex method is the following from the linear programming problem in standard form. Right. Minimize z equal to objective function is given. Right. Now this fellow is our objective function, say A. Now the constraints are given st x3 so and so 2 plus 2x1 minus x2, x4 is equal to 7 plus x1 minus 2x2. Now x5 is equal to 3 minus x1, and x1, x2, x3, x4, x5 are greater than 0. Here the objective function is written as a function of non-basic variables. If the simplex method moves to the adjustment of basic feasible solution v1 to the power r5, that best improves the objective function. Right? So which follows the represents the objective function at v1, assuming that objective function is written in the same manner as above. So now here we need to rewrite the objective function. Okay, so we need to rewrite the objective function. I will look on this, guys. Now, how to solve this question? I'll tell you in a simple words. Right? Right. Now let us solve this question. I have a solution. So step by step, I'm going to explain you guys. Right. Now let us move forward. So write the objective function first. Now z is equal to, it is going to be a minus x1 minus 2x2. All right, guys. Minus x1 minus 2x2. So now say this fellow is my objective function. Say a. Right. Now x3. x3 is equal to 2 plus 2x1 minus x2. Right. Now x4 is equal to, it is going to be a 7 plus x1 minus 2x2. Similarly, x5 is equal to, it is going to be a 3 minus x1. Similarly, just check it, 3 minus x1. Right. Now from equation, say it is equation number 1, it is equation number 2, say it is equation number 3. All right, guys. Right. From equation number 1, I'll change the ink. From equation number 1. From equation number 1, right? Now, from equation number 1, I can write it is x2 is equal to, it is going to be a 2 plus 2 x1 minus 3. So, it is 2 plus 2 x1 minus x3. What do you say, guys? Right? Now, put this value in the objective function a. Right? Now, our procedure, put this value in objective function a. Objective function a. All right, guys. Right now, what's x2? Keep the x2 in place of this one. Right now, my objective function z is equal to minus x1 minus 2x2, such that if I write that, then minus x1 minus 2 into, what is my x2? x2 is equal to 2 plus 2x1 minus x3. Right now, if I write my simple form of my equation, then it is going to be a minus 4 minus 5x1 plus 2x3. Right? If I send minus 2 inside, minus 4 will come. So minus 4x1. 4 minus 4x1, 2 into 2, 4x1 minus x1 minus 5x1 minus into minus plus 2x3. Hope you understand. Right? Now let us find that from equation number 2. So we have solved this one. Right? Next. From equation number 2. From equation 2. Right? From equation number 2. I can write my x1. x1 is equal to x4 plus 2x2 minus 7. Right, guys? Right? Here from equation number 2, I wrote x2. I'm writing x2. That's it. So sending x2 this side and getting the x4 this side. That's it. Nothing is there. Nothing is there. Right? Now I hope you understand. I hope you understand. Right? Now put this value again in objective function. Put this value in objective function. right, in A. Now here, what is my objective function? Z is equal to, it is going to be a objective function minus x1 minus 2x2 minus x1 minus 2x2, right? Now here I know that, x1 value, so minus into, it is going to be a, I'll write simply x4 plus 2x2 minus 7 minus 2x2, right? Now here write it, send this inside, minus x4 minus 2x2 plus 7 minus 2x2. Alright. Now here it is going to be a plus 7 minus 2x2 minus 2x2 minus 4x2 and then minus x4. Right. Now this is also not given. Right. Now from equation number 3. Let's take from equation number 3. From equation number 3. So what is equation number 3? Now let us go back. Equation number 3. X5 is equal to 3 minus x1. X5 is equal to 3 minus x1. Alright. Now again substitute this in this value, put in objective function. Objective function such that right. Now let us write that my objective function z is equal to, it's gonna be a x1. So from equation number 3 I can write my x1 is equal to, it is gonna be a 3 minus x5. 3 minus x5, right? Now z equal to minus 3 minus x5 minus 2x2, right? Now if I simplify this, 3 plus x5 minus 2x2. Alright? Right. Now here, so B and D are both are correct, but see, B and D are both are correct. Minus 6, minus 4, minus 5 to x3. But formation of equation is MCQ. That is why your option is D. Your option is D. Right. Now answer is. Alright guys. Now let us move for another question. Now, in supplier retailer supply chain, the demand for each retailer is a capacity of each supplier and unit cost in rupees of material supply each supplier to each retailer are tabulated below. The supply chain managers wishes to minimize the total cost of transportation across the supply chain management. Across the supply chain management, right? Now, so here retailer and supplier is given, right? Now 4 suppliers and 4 retailers are there, right? It is an assignment model, right? Transportation and assignment model. To optimal cost satisfy the total demand for all retailers, right? It is not like job sequence and jobs and missions, right? How many rows are there? How many suppliers are there? How many retailers are there? That means supply and demand is going to be equal. So this is a retailer demand and here going to be supplier. So 4 suppliers, 4 demand. So 4 by 4 matrix, right? Now let us apply Hungarian method, right? Hungarian method we have to use, right? Now here Hungarian method we are supposed to use. Clear? Right. Now let us first write the columns and rows. Right. Now here what is 11, 16, 19, 13. 11, 16, 19, 13. Right. Now I have a solution. All the time it is not possible to go back. Right. Now let's write that 11, 16, and 19, 13. 19 and 13. Similarly, 5, 10, then 7 and 8, and then 12, 14, and then 17 and 11, and then 8, 15, 11, and 9. Right? Now, guys, let me draw this in a proper way. Right. Now, I just draw the rows and columns. 4 rows and 4 columns are there. Now, according to the Hungarian method, first we need to find the minimum in all rows. First, we'll do that column operation. For column operation, we can do anyone, either column operation first or row operation first. Right now, here find out that minimum in this column. What is the minimum in this column? 5. In this column, minimum is 10. In this column, minimum is 7. Now, in this column, minimum is 8. Right now, detect this 5 in this column. Detect this 10 from this column. Detect 7 in this column. Detect 8 in this column. Right now, if I detect 5 in this column, what happened? So now revised will come. Revised will come. So now let me go for column operation. This is a column operation, guys. Right now, revised row, you just write revised row. That is, 5 minus 11 minus 5, 6, 5 minus 5, 0, 12 minus 5, 7, 5, 8, 8 minus 5, 3. Right now, here new row will come 6, and it is going to be a 0 new column. Then I'm detecting 5 from my first column. Right, first column. Right now, it is going to be a 7, and it is going to be a 8 minus 5, 3. Right, next 10, it is going to be a 6, 0, and then 4, and then 5. Right, next I'm just deducting the 7 from all the elements in the column. Right now, 12, 0, 10, 4. Similarly, 8 remove. So 8 remove 5. 8 deducting from this column of every element. So 8 minus 8, 0. 11 minus 8, it is going to be 11 minus 8, 3. Right now, 9 minus 8, 1. Right now, we just form a again simple row. So after column operation, we got this one. After column operation, we got this one. Right? Right. Now we just draw this. Alright, guys. Right. Now go for row operation. Row operation. Next step is row operation. Right? That means find the minimum in all the rows. Find the minimum in all rows. Find the minimum in all rows. Now let us find that minimum in this row. In this row, minimum row here, column 1, column 2, column 3, and column 4. Right? So now here R1, R2. So for your understanding, I'm writing, guys, R4. Right now here, similarly revised after column operation. After column operation, we got this. Right now, everywhere it is not possible to write. Now find that minimum in this row. 5, 0, minimum in this row. 3, minimum in this row. Right now, so row operation. It is a column operation and it is a row operation. Now after row operation, right now 5 deduct from all the row. 5 minus 6 minus 5, 1, 6 minus 5, 1, 12 minus 5, 7, 5 minus 5, 0. Right, first row I'm writing. Right now here I use different things so that it is easy to you to differentiate, right? Now 6 minus 5, 1, 1, 7, and 0, right? Similarly, 0, this will come same row, 0, 0, 0, right? Next is 3, you deduct from every element, 7 minus 3, 4, 3 minus 4, 1, 10 minus 3, 7, and it is going to be a 0, right? Now, let's go to this one. 1, you deduct 1, 2, 4, 3, 1, right? Now, you just draw the column. This one, this one, and this one, right? Strike out that which covers maximum rows and maximum columns, which covers maximum rows and maximum columns, right? I'm going to strike. I'm going to strike 1 minus 1 here, 0, na? Oh my god. I'm sorry. It's going to be a 0. Now I'm going to strike which covers maximum zeros. This one and this one. The next step is that find the minimum among all non-striking elements. Non-striking elements means non-striking, 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 right? From all these elements, right? Find the minimum. This one will be the minimum, right? Now you just deduct all these from non-striking elements, right? 1 minus 1 0, 1 minus 1 0, 6, 7 minus 1 6, right? Now again 4 minus 1 3, 1 minus 1 0, and 7 minus 1 6, and 2 minus 1 1, 4 minus 1 3, 3 minus 1 2, like that. Find the minimum one among the non-striking elements, deduct this one from the non-striking elements only, right? Now here, oh, what I'm going to get, 0 0 3 1, right? Now I'm going to get 0 here, 0 3 1, 3 1. Next is 0 0 3, 0 0 0, and 3 will come, right? Now next is you're going to get 6 0 6 2, 0 6 2. Next is you will get all zeros there, right? Now you strike which covers maximum zeros. Now let me draw the outline. Now strike the which covers maximum zeros and maximum. This one I will strike, and this one I'll strike, and here this one strike, and this one I'm going to strike. Right, guys. All right. Now let's our maximum number of lines is equal to order of matrix, and this optimal because each row and column preciously are encircled by 0. Okay, right now let me write the statement so that you will be able to understand properly. So as minimum number of lines, as minimum number of lines, minimum number of lines is equal to is equal to order of matrix, order of matrix, and this optimal because, and this optimal because each row and column preciously encircled by 0. Each row and column encircled by 0. Right? 0. Right? Let me write this one properly. Now let me write this one properly. Now here, what is that? 0, 0, 6, 0. Right? And 0, 0, 0, 0. And here 3, 0, 6, 0. 1, 3, 2, 0. Right? Now here let me draw the lines. Alright guys. Right. Now here I will just allow this one. So here if I allow this one, then this row will get cancelled. So that is the reason why here I allow this one. Next this one, and here lost this one. Right. Now if I allot here, then I do not allow any column, any row in this element. Right. If I allot here, then there will be a no 0 in the column 3. That is why here I allow this here second, and here 0 allow, and here allow this one. Hope you understand guys. Hope you understand. See, if I allow here this one, then what happened? I should not allow this. I should not allow this. Then there will be a no 0 in the column 1. Right. Now here we have to encircle this one. Okay. Hope you understand guys. Right. Now let me write this. C1, C2, C3 and C4. R1, R2, R3 and R4. Right. Now here, so what we're going to get here, R1 assigned for C1. Now here R2 assigned for C3, R3 assigned for C2, now R4 assigned for C4. Clear everybody? Right. Now optimum solution is add all those R1C, R1C, R1C. So here C1, C2, C3 and C4. Now here it is R1, R2, R3 and R4. Now it is going to be a R1 C1. So what is the value here? 11. So that we just use 11 plus next R2 C3. Right. R2 C3. R2 is C3. Now it is going to be a 7. Add this one 7 plus next R3 C2. R3 C2. This is the value. Then we just add this plus 14. Next R4 C4. Right. R4 C4 is 9 plus 9. Right. Now the total cost is, everything is retailer and supplier, the cost is providing 300. That is why you just multiply with the 300. Right. Now here, then you are going to get this 12,000. 12,300. Now your answer is 12,300 rupees. Right. Hope you understand guys. Hope you understand. That's all. These are the questions that are coming from industrial. 5 questions we have solved. Okay. Right. Now